Welcome to the webinar, Breaking Through the Sustainable Packaging Dilemma, Carbon Footprint versus Waste Management. My name is Kristen Marshall. I'm an Associate Research Director here at Lux, and I'll be moderating today's session. Presenting today is my colleague, Martian Lee. He's an analyst here at Lux. And throughout the webinar, you can type questions you have in the question box on your screen. Time permitting, we'll answer all the questions that we can. But if your questions don't get answered, do not hesitate to reach out to questions@luxresearchinc.com, and we will respond. Now, let's jump into the presentation. Take it away, Martian.
Thanks, Kristen. Good day. My name is Martian, and I'll be sharing on breaking through the sustainable packaging dilemma. So the transition to sustainable packaging often involves making some very hard decisions, especially when we need to make trade-offs between multiple different sustainability considerations at the same time. So today I'll be sharing one way that we can think about the issue and how we could overcome this sustainability dilemma. So before we get into the content, I would like to share a short story about one of our most famous brands, McDonald's. Back in the 1960s, McDonald's was using paper packaging, and in the 1970s, McDonald's continued to use more paper packaging in the form of cardboard. And that was roughly the time when plastic started to enter the market. At that point in time, it was in fact considered virtuous to transition away from paper to plastics because deforestation and saving the trees was the hot button sustainability issue. Then in the 1980s, McDonald's switched over to polystyrene foam, but very quickly consumers realized that polystyrene foam isn't doing us any favors when it comes to environmental sustainability. And the public backlash was so strong that there was even a public campaign against McDonald's against their use of polystyrene foam packaging. So let's fast forward this a couple of decades later, and we are back to square one, and McDonald's is back to using paper packaging again. So the moral of the story is that the definition of sustainable packaging can and will change with time. As our understanding of sustainability grows, it is no longer just a single factor consideration. And that's where the dilemma arises. And today I'll first put things into context with an introduction into the sustainable packaging dilemma. Then I'll share about one way that we can break through this dilemma, followed by wrapping it up with some next steps. So the sustainable packaging dilemma. Sustainable packaging often requires balancing between several environmental impacts at the same time. And if we were to do a full life cycle analysis of any material, there are at least 11 different impacts to consider. And I can say with certainty that today there is no viable alternative packaging material that can give us a benefit across all 11 sustainability impacts when compared with virgin plastic materials. Let's take polyethylene as an example. You could get a pretty good reduction in climate change, a decent reduction in ecotoxicity impacts, but you are almost twice as bad when it comes to aquatic eutrophication and ozone depletion. So the question here would be, is it worth being worse off in all other sustainability impacts just so that we can get a benefit in one, which is climate change? And trying to make this decision is made even harder because we are running out of time. We are in 2024 this year, and we would expect the UN to release a legally binding plastics treaty. And this is going to make the consumption of virgin plastics all that much harder and more expensive. And between now and 2030, we're going to expect a number of sustainable packaging regulations to come into play, including the EU's enforcement of recycled content mandates, deadlines for extended producer responsibility schemes, as well as other eco-design regulations along the way. So looking at this timeline, we have about 6 years left to complete our transition to sustainable packaging materials. However, recall that we do not have a perfect material as of today. We don't really have time to wait for a perfect material to be discovered and scaled up for us to make our deadlines by 2030. And so we have to start thinking about what we have and how we can make the most out of these available resources. So Lux has identified 9 alternative packaging materials that can have a real impact on your sustainable packaging goals. And I would suspect that most of these materials here are not unfamiliar. So they include options like reusable packaging, recycled plastics, non-fossil plastics, and so on. Most importantly, these packaging alternatives are at scale. They are commercialized or at least close to commercialization. And so we have a good chance of being able to adopt them at large volumes, at significant volumes in time for our 2030 deadlines. And now that we have identified a number of candidate materials, we have to think about how we can assess them when it comes to sustainability. One of the main, one of the most common dilemmas that we have heard so far from industry is that, on the one hand, if a company wants to reduce its carbon footprint, then they will go all in with plastics. This makes sense because plastics are lightweight and they objectively have a pretty low carbon footprint of a little more than 1 kilogram of CO2 equivalent per kilogram of material. On the other hand, if the company wants to maximize its circularity goals, then they will go all in with metals. Metals like steel and aluminum enjoy very high recycling rates, often in the range of about 80%, and they can incorporate very high levels of recycled content without any degradation to the quality of the packaging. However, the issue comes in when the company wants to achieve both a reduction in its carbon footprint as well as improve on the circularity of its packaging material. Then the company is stuck, right? It is in a position where it has to choose between one way or the other, or not transition at all. And so I think that there's a way that you can break through of this dilemma by changing how we view sustainability. And from what we could gather from industry, the main concerns when it comes to sustainable packaging can be distilled down to two main priorities, which is carbon footprint and waste management. Carbon footprint is straightforward enough. There is a global policy that is seeking to reduce carbon emissions in an effort to curb climate change. And carbon footprint can have a very tangible financial cost associated with it through the form of carbon taxes. Waste management is less straightforward, and it is related to the physical accumulation of plastic waste. This is not limited to mismanaged plastic waste that is leaking into the environment, but it also includes plastic waste that is going through our formal waste management systems and ending up in the landfills or incinerators. At this point of a product's life cycle, recycling is definitely the preferable option, but it is very challenging for us to determine the recyclability of one material over the other when we're making some sort of comparison. One way we can do that is through extended producer responsibility fees. Extended producer responsibility is a program where businesses that put packaging materials into a market becomes responsible for the packaging's end of life as well. And this often constitutes a financial contribution through EPR fees. In regions with eco-modulated EPR schemes, materials and packaging formats that are easier to recycle tend to attract a lower EPR fee, while materials and packaging formats that are harder to recycle tend to attract a higher EPR fee. And by using EPR fees as a benchmark, we now have a way to quantitatively compare between the recyclability of our different packaging options. But more importantly, this also gives us a common denominator when we are trying to compare between the two different aspects of carbon footprint and waste management, and when we try to make when we have to manage our trade-offs between these two different sustainability impacts. So now that we are clear on how we are going to assess our sustainable packaging alternatives, we can then do a two-factor analysis to help us identify where to focus most of our research and our investment efforts on. And in the green quadrant, we have our tier 1 materials that would give us both a decrease in waste management and carbon footprint cost. And these are the materials that you should focus your investments at because they would give us the greatest overall sustainability benefit. And then in our orange quadrant, we have materials that will give us one improvement in one aspect, but not the other. And these materials are still worth a look, still worth some attention to it, but it is important to think of them as longer-term prospects that will require additional investments, additional research and development in order for us to achieve the greatest sustainability benefit from the adoption. In the gray section, we have materials that we cannot make a good decision on right now, because it should be evaluated on a case-by-case basis. There are simply too many factors that can impact the sustainability of such materials. And finally, in our red quadrant, we have materials that will give us neither an increase, a benefit in waste management nor carbon footprint. And you would do well to avoid these materials unless there's a very compelling reason for you to look into them. And so let's plot our candidate materials with these two-factor analyses. And we will see that mechanically recycled plastics and reusable packaging would fall under our green quadrant tier 1 materials. And I would say that this outcome is not unexpected. So mechanically recycled plastics, there is general agreement that they can give you a carbon footprint reduction when compared with virgin plastics. And overall, when it comes to waste management costs, eco-modulated EPR schemes will give you a bonus or a discount when a company consumes a certain amount of recycled material. Besides EPR regulations, there are also regulations like the UK's plastic tax, which imposes a tax on packaging materials that do not contain a certain amount of recycled content. And by adopting mechanically recycled plastics, we can avoid this tax, and it can be seen as a bonus when it comes to waste management costs. So while mechanically recycled plastics can give us great sustainability benefits, one of the main challenges with the material is its limited availability. And this is especially so if we intend to use these recycled materials for some high-value applications, like food contact packaging, for example. And our second tier 1 material would be reusable packaging. Reusable packaging is not strictly a type of packaging material, but rather a consumption model for packaging. And the beauty of reusable packaging is that we can average out the carbon footprint across a number of reuse cycles. As long as the consumer continues to reuse this piece of packaging, there will come a point in time where the carbon footprint, the average carbon footprint of the reusable packaging will be the same as an equivalent number of single-use alternative. If the consumer continues to reuse this packaging beyond this break-even point, the carbon footprint of the reusable packaging will be reduced even further. When it comes to waste management costs, we would also expect reusable packaging to give us a reduction simply because we are putting less material into the markets. In fact, there are also EPR schemes in certain regions that completely exempt reusable packaging from EPR fees. So while reusable packaging overall gives us a great sustainability benefit, it is quite straightforward, but the success from using reusable packaging will hinge entirely on consumers doing the right thing, which is to reuse that piece of packaging as intended. So moving on into our orange quadrants, we have drop-in bioplastics and monomaterials that give us a decrease in carbon footprint, but not really a benefit when it comes to waste management. And you will notice that there are no materials in the top left quadrant, which would be where materials that give us a decrease in waste management costs but no benefit in carbon footprint will sit. This is because when a piece of packaging has better end-of-life prospects, which is related to its a decrease in waste management costs, we can also expect a positive impact when it comes to carbon footprint reduction. And so it's very unlikely for any material to have great end-of-life prospects, but having a poor carbon footprint because of this relationship. And for these types of materials, I'd like to highlight monomaterials, where it is very important to distinguish between practical and technical recyclability. So let's take Colgate's monomaterial toothpaste tubes, for example. Traditional toothpaste tubes contain a metallized liner, and that makes them impossible to mechanically recycle. And Colgate's solution is to develop a monomaterial toothpaste tube that does not contain this metal liner, and this makes it technically recyclable. However, when it comes to practical recyclability, recyclers have no way to distinguish between toothpaste tubes that contain a metal liner and Colgate's toothpaste tubes that do not contain this metal liner. As a result, it is just as likely for Colgate's toothpaste tubes to still be sent for landfill or incineration. And because of this difference between practical and technical recyclability, Colgate is currently facing a lawsuit when it comes to because of greenwashing accusations. So the point of this, the main takeaway from this is that although monomaterials can give us some sort of sustainability benefit, just adopting monomaterials on its own is not enough, and we have to have accompanying developments in the waste supply chain in the way that we sort and process waste materials in order to reap the biggest benefit out of our transition to monomaterials. And moving on into our gray section, we have chemically recycled plastics, metal packaging, paper packaging, and I would like to highlight metal packaging because the assumption is that metal packaging will have a higher carbon footprint than plastics in general. And this is only true when it comes to a material to material comparison, because if we were to start taking in considerations like metals that have very high recycled content, or if we take into consideration the very high local recycling rates of metal packaging, there is a chance that metal packaging can have a similar or even lower carbon footprint than plastic packaging materials for some applications. Similarly, when it comes to waste management, metal packaging tend to attract a much lower EPR fee because they are a lot more easily recyclable than plastics, but metal packaging can be heavier, and this would affect what is the net waste management cost when it comes to EPR fees. So the point of this is that let's not be too hasty with writing off metal packaging as a sustainable form of packaging material. And the actual environmental impacts of using metal packaging would depend very heavily on packaging design and its applications. Finally, moving into our red quadrant, we have compostable materials and glass packaging. And for these materials, I would like to highlight compostable materials and using PLA as an example. The only way for PLA packaging to have a more favorable carbon footprint than our virgin fossil-based plastics would be if the PLA packaging goes to composting. But we know that this is not happening in reality. And so in general, using compostable materials will not give you any sort of carbon footprint benefit when we look at it from a cradle to grave perspective. When it comes to waste management, compostable materials like PLA are not typically recycled, and they are undesirable because they can contaminate the recycling streams and bring down the overall quality of recycled plastics at the recycler's point. So oftentimes, compostable materials can attract a higher EPR fee than fossil-based plastics. So while in general, we will most likely not be able to make a strong business case when it comes to sustainability with compostable plastics, it is also important to consider local circumstances that can influence the way that we view these type of packaging materials. So now that we have done our initial assessment, we have decided, we found out that reusable packaging and mechanical recycled plastics would pretty much give us a good sustainability benefit. There are some next steps that we can do in order to do a final level analysis and choose what is the best option. And one way to do that is to pay attention to the true financial cost of using a particular type of packaging material. So if we were to sum up the carbon footprint cost and the waste management costs and add that on top of the actual cost of the cost of the packaging itself, we can find out what is the actual cost associated with using a certain type of packaging material. And we can see that this sustainability cost, which is the sum of your carbon footprint and your waste management costs, can have a very big impact on how these different packaging materials match up. And from this chart here, there are a couple of things I want to highlight. Firstly, the carbon footprint of virgin plastics is so low that the tax associated with it is pretty insignificant when compared with all other costs. And this carbon tax is represented by a light pink bar in the chart, and you can barely see it making any difference. And the second point to make here is that the waste management costs or extended producer responsibilities, as represented by the dark green bar, is actually going to be your greatest sustainability cost overall, and it can have a very big impact on how we view the associated costs with using a certain type of packaging material. So the question is, if carbon footprint is going to be so insignificant, then is it worth still having carbon footprint and carbon taxes as one of our main priorities when choosing between sustainable materials, alternative to our packaging materials? And the next point to highlight is that we have to recognize that some of these solutions, the positions of some of these solutions are dynamic. And they can depend on a number of external developments beyond just packaging technology. So, for example, the energy transition to renewable energy can have a big impact on the carbon footprint of materials that have very high manufacturing energy intensities. And this can have an impact on where some materials like compostable materials and chemically recycled plastics sit on our two-factor analysis. Similarly, improvements to waste management infrastructure can influence how we view things, how we categorize products as being recyclable or unrecyclable. And with improvements to sorting technologies, to the way that we separate certain materials for recycling, we can see we might possibly see monomaterials improve from an orange quadrant to a green quadrant. And finally, there are policy changes that can directly incentivize or disincentivize the use of certain materials. And this is especially true for compostable materials. While in some regions, compostable materials are not seen very favorably, especially in the West, certain regions like India and China instead have mandated the use of compostable materials when it comes to things like plastic bags, for example. So regardless the sustainability impact of using the actual calculated sustainability impact of these of compostable materials, policy can have a direct influence on whether it is an option or not. And finally, we also have to consider what other priorities are emerging and adjust our view of sustainability with these changes. So for this, I'd like to take us back to our story about McDonald's. And I think that we are on the cusp of a very similar revolution today. We have been using plastic packaging materials for a while now, and we have realized that the way that we consume it is not sustainable. Right? And one of our solutions to this is to recycle our plastics and transition over to a circular economy. However, recall that mechanically recycled plastics are in our tier 1 materials, but a recent study has shown that mechanical recycling can actually lead to the production of very high quantities of microplastics. Microplastics is an area of growing concern, and we have seen it influence policy like bans in the use of microbeads in skincare products, or even bans in the use of granulated tires for surface materials over fear of microplastics leaching into the environment. So at the moment, it is still it's still uncertain whether microplastics will have any sort of direct implication on how we view recycled plastics and plastics recycling. But this is definitely a development that is worth looking out for. And to end this presentation with some key takeaways. Number one, we are very unlikely to see a perfect alternative material be scaled up within our very short timelines. And so we need to work with what we have because of the urgency of the matter. Secondly, we have to prioritize what are our most important sustainability impacts in order to move forward and make a decision. Trying to balance between 11 different impacts at the same time is not a great idea, and most likely is going to hinder any sort of progress, any sort of transition to sustainable packaging. And finally, what is sustainable today may not be so tomorrow, and we have to be alert to emerging trends and adjust our perspective and our view of sustainability accordingly with these changes. And this is the end of my presentation. Thank you for your attention.
Thanks, Martian. Okay, we will now be taking questions from the audience, which you can type into the questions box. And again, if we do not get to your questions on this presentation or during this call, someone from Lux will be back in touch with you. Okay. So to start, I see one question here. So it's really interesting that relative to waste management costs, carbon costs are so low. So if carbon costs are going to be so low, is it still worth having it as one of our primary assessment criteria here when evaluating these different solutions?
My answer would be yes. And I think that is because there are a lot of more different implications associated with carbon footprint than just the carbon taxes, right? Especially when carbon footprint is such a huge part of the conversation around sustainability today. And there are possibly going to be an indirect costs associated with carbon footprint, like how it influences consumer buying behavior, or how it can impact the types of financial instruments like grants and loans that certain companies can have access to as a result of its carbon footprint. So overall, I think although carbon footprint is not going to be the biggest influencing factor when we are trying to compare between carbon footprint or waste management, it is still an important consideration to have when we are deciding between different materials relative to virgin plastic materials when we make our decision on what is more sustainable or not.
Okay. The next question, with regards to product-specific requirements, how does your methodology incorporate those types of requirements like barrier properties or mechanical strength when making choices?
So the methodology is focused entirely on just sustainability. But when it comes to functional qualities like mechanical strength, optical clarity, gas or vapor barrier properties, this should be made at the point when we are deciding between candidate materials. And only after we have filtered out candidate materials that can fulfill these functional requirements, then we do our next step, which is the sustainability assessment that we have done here today. Because after all, what's the point of choosing a very sustainable material that ticks all the boxes when it comes to environmental impacts, but it doesn't fulfill its function of protecting this consumer good in the first place?
Yep, you want it to work, for sure. So, and then I think we have time for just one more question, and this one is on compostable plastics. So they didn't really do well here in terms of your assessment, but do you think composting or recycling will ever be a practical end-of-life solution or option for compostable materials?
I think yes, but in the distant future, right? And that is because there is growing concern and regulatory focus on food waste management and how we have to do composting or digesting of food waste in order to prevent the methane production from when food waste is decomposing, right? And I think it is possible that with this build-up of infrastructure for food waste management, bioplastics and compostable plastics like PLA can piggyback on this infrastructure in order to have a more preferable end-of-life outcome. However, besides this physical build-up of composting capacity, there's currently a mismatch between compostability standards and certifications, and with the properties and the composting behavior that composters need in order to accept compostable materials in their feedstock. So that is the second problem that compostable materials will have to overcome, which is a harmonized compostability standard that is aligned with actual composting conditions in order for this actual composting of compostable materials and bioplastics to happen at scale in the future.
Okay. Well, thank you very much, Martian. This concludes our webinar for today. The slide presentation and recording from this webinar will be sent to all attendees via email. After leaving the webinar, you'll be prompted to conclude a survey on today's presentation, which we would very much appreciate any feedback that you have to help us inform future webinars. And please take a moment to check out upcoming webinars. Thank you so much for joining us and have a great day.